Okay, good afternoon, class. So today we're looking at geometry. However, we're doing geometry, quadrilaterals in particular, and we're looking at page 10. Correct? Alright. In this lesson, we're going to look at page 10 and 11. So here we are told that ABCD is a trapezium. You say, this is a trapezium, what do we know? There's one property of trapezium, which is one pair of opposite sides are parallel. And this is an isosceles trapezium, then that is parallel and these lengths are equal. Okay? So we are told that ABCD is a trapezium with AD being parallel to BC. So we are told that it is parallel but not written in, so we can fill it in. No reason required. Because in the diagram, it's in the information given. Then we are told that AB is equal to AD, which means to say that D and C is the same angle, angles opposite equal sides. Then we are also told that BD is equal to BC, which makes AD, angles opposite equal sides. Then angle C is 80, determine the unknown angles. So let's go. So already I said that A is equal to 80. Why? Angles opposite equal sides. Okay. Now I can calculate B. So B is equal to 180 minus 2 times 80, which is 20 degrees. Why? Sum of triangles. And this triangle, DBC. You don't have to say the spot. Okay? So these two. So we know that these lines are equal, parallel. So alternate angles are equal. So C would be 20 degrees. Angle C is 21, which is alternate angles with AD being parallel to BC. Okay. D is 21, angles opposite equal sides. Angles opposite equal sides. And then E is going to be, we can work this out by using angles in the triangle, sum of triangles. So angle E is equal to 180 minus 20 minus 20, which is 2 times 20, which gives you an answer 140. Sum of triangles in triangle ABD. Okay? Any confusion there? So that is A. Let's look at B. B, we are told that ABCD is a parallelogram. People, if ABCD is a parallelogram, what do you mean? 4 things should come to mind. Firstly, opposite sides are equal. 2 pairs of opposite sides are parallel. Opposite angles are equal. And diagonals bisect each other. But there's not another diagonal here, so that rule doesn't apply here. Okay. Question says calculate x. Okay. So we basically know that we can form alternate angles. This angle is equal to this angle if those lines are parallel. Not so. The lines are parallel. Not so? So we can then say 60 plus x is equal to 150. Alternate angles. But we can't go straight into it because there's no parallel lines on the diagram. We must qualify it first. Okay? So we firstly got to say that AD AD is parallel to BC. That's all. But BC is the same as BE or BCE. Why is that the case? Because two pairs of opposite sides parallel in a parallelogram or a palm. So now I can legally write that in there. If you're not going to do that step, you're going to do some more or two. Okay? So now we're saying that alternate angles can be applied. So we say 60 plus x, which is this angle here, is equal to 150. Why? Alternate angles are equal with AD being parallel to BCE or BC or BE or CE, whatever. So now I can solve for x. So x is equal to 150 minus 60. And what's 150 minus 60? 90 degrees. Okay? Any confusion there? Look at C. Here we are told that ABCD is a parallelogram. Calculate x. If this is a parallelogram, what do we know? We know four things. Two pairs of opposite sides are equal. Two pairs of opposite sides are parallel. Opposite angles are equal. And this whole angle is equal to this angle. And the angles bisect each other. We know the angles. However, we know that these lines are parallel. If these lines are parallel, what can we do? We go with going through the angles. You see that, people? You must first state it. You can't just go with it. So you first say that AD is parallel to BC. Why? Two pairs of opposite sides parallel in parallelogram. Okay. Now we're going to go with that co-interior story. So x plus 2x, so we could have said 3x plus 150 adds up to 180. Why? Co-interior angles with AD being parallel to. So this 3x not so. It's equal to 180 minus 150, which is 30 degrees. But divide by 3 both sides. So x works out to be 10. Okay. You still on page 10?
Yes, sir.
D. We are told that ABCD is a rhombus. Six or five come to mind. 6 or 5 properties come to mind. Okay? So what are the properties? All sides are equal. That's number 1. Number 2, opposite sides are? Two pairs of opposite sides are parallel. Number 3. Sorry? What? Opposite angles are equal. Yes. What else? That is 3, no? The angles bisect each other. 4. Another one? The angles bisect the vertex angle. So those angles are equal there. Whilst that is equal to. That's 5. One more. The angles are perpendicular. There's 6 in the rhombus. Doesn't sound like you guys actually read what you wrote down. Okay? So there are 6 properties. When they tell you it's a rhombus, all of those things must come to mind. Okay? So let's go with what we have here. The question says calculate x, so solve for x. So this is a rhombus, so those lengths are equal, not so. Both sides are equal, which means to say A1 is equal to x. Angles opposite equal sides, and then we can go with summing triangles. That's one way. Otherwise, we can firstly say that C1 is x. Why C1 x? Because the angle, the diagonal bisect the vertex angles. Can you see that? So C1 is x. Why? Because the diagonals bisect the vertex angles. Then I can say that these lines are parallel. Two pairs of opposite sides are parallel in a rhombus. Then I can go with co-interior. You're going to get the same answer. And I'm sure there's many other ways we could have done it as well. Okay? And I'm going to do all the ways. I'm just going to do the first way that I've written down. So firstly, we know that AB is equal to BC. Why? Because all sides equal in a rhombus. Okay. Now, A1 is x. Why is A1 x? Angles opposite equal sides. Now what? X plus 50 is 2x plus 50 equals 180. Why? Sum of triangles. This triangle ABC. Okay? So that now simply works out to be 2x is equal to 180 minus 50, which is 130. Not so. Divided by 2, therefore x is equal to 65. Okay? So we're on page 11 now, okay? Ready? Page 11. So here we are told that ABCD is a parallelogram. Four things comes to mind. You'll see me always reminding myself what is evident in a parallelogram. There are four. Yeah? How is the four properties? How can we link it to this? Firstly, two pairs of opposite sides are equal, two pairs of opposite sides are parallel. Okay? Opposite angles are equal, and the angles bisect each other. Okay? The question says calculate x and y. But from the offset, we know we can calculate y. Not so? So we're going to firstly say that 80 is equal to 140 minus 2y. Reason? It's vertically opposite. So we can take that over. So 2y is equal to 140 minus 80, which is 60. Divided by 2 both sides. So x is 30 degrees. Y is 30, sorry. Y is 30. Okay. So that means to say that y is also 30. And this angle, of course, we now know it's 80. You all agree with that? Now what? Now we can go with sum of triangles, but what are we shorting here? Angle C. But what is angle C equal to? 80. Not so? The angle C is 80. Why? Two pairs of opposite angles equal in parallelogram. Can you see that, people? So that is now 80. Now what? You can say x plus 80 plus 30 equals 180. Why? Sum of triangles. And its triangle DBC. So x is equal to 70 degrees. Okay. Any confusion there? If Here we are told that ABCD is a parallelogram. So ABCD is a parallelogram, 14 come to mind. That length is if opposite sides are parallel. Two pieces of opposite sides are parallel. Two pieces of opposite sides are equal. Opposite angle, two pieces of opposite angles are equal. And diagonals, there's no diagonals here, but bisect each other. Right, so what can be calculated first? X. Not so, because this angle is 60y. Angles opposite equal sides. And then I can go with sum in triangles. Okay. So first angle B is equal to X. Y. Angles opposite equal sides. You can't say isosceles triangles. Okay. So 60 is here. And now sum in triangles. So X plus 60 equals 180. Sum of triangles is triangle BAE. So that's 120. So X is equal to 180 minus 120, which is 60. This is also what, people? What type of triangle is this? Equilateral triangle. So which means to say, this is actually the midpoint of this line here. Not so? Why? Because all of this will get the same marking now. Can you see that? Okay, that wasn't awesome. Let's look at y. How are you going to calculate y? Sorry? Opposite angles in a parallelogram. But we don't have two. But we can get it. Because these lines are almost parallel, not so. So alternate angles are equal. So that's also 60. Okay? So firstly we must say that AD is parallel to BC. Why? Because we got two pairs of opposite sides parallel in a parallelogram. Then I can draw that in. It's parallel. Now we can say that A2 is 60. Angle A2 is 60. Why? Because alternate angles are with AD being parallel to BC. We don't write the parallel lines in here. Be prepared to do as a mark there, okay? And now we know that this angle here is equal to that whole angle there. So y is equal to 60 plus 60. Or we could have just written 120. Y, two pairs of opposite angles, not sides. Two pairs of opposite angles equal in a parallelogram. Okay? So there's now 120. How are you going to calculate Z? How are you going to calculate Z? Z I can calculate many ways. Angles on a straight line, you will calculate E3. That's so? You can calculate Z in that triangle. You will calculate D1. Okay? I can go with exterior angle of triangle if I got angle D2. There's many ways of calculating Z. I'm sure there's more than that as well. I use opposite angles in the parallelogram as well. I'm sure that could be useful as well. Okay. But what do we know? We must first calculate D2. Not so. But D2 we know it's the same as E3. Why? Because AB is the same as DC. With that being said, here we got an isosceles triangle now. Not so, with base angles being equal. Okay, so let's go with that. We know that DC is equal to AB. Why? Two pairs of opposite sides equal in parallelogram. So now we got the same marking here. Can you see? It's all the same. So D2 is equal to E3, sorry. The reason for that is angles opposite equal sides. So I'm going to calculate E3. So I know that we're going to go with sum of triangles now. Right? So E3 plus angle D2, which is the same as E3. So it's twice E3. Okay? Plus 120 is equal to 180. Why? Sum of triangles. And this triangle, DEC. Okay. So now that I can take over the equal sign. So 2E3 is equal to 180 minus 120, which is 60 degrees. Divided by 2, so E3 will give you 30 degrees. But they ever answer the question? No. So, remember this is not 30 degrees. So I'm going to go with angles on a straight line. So 60 degrees plus Z plus 30 is equal to 180. Why? Angles on a straight line. So Z works out to be 180 minus 60, which is whatever. Minus 30 is going to give you 90 degrees. Okay. So angle Z, or Z is 90 degrees. Okay. You still on page 11? The question says ABCD is a square. There are 6 properties that comes to mind for a square. What are the properties? All sides are equal. 7 actually. No? All sides are equal. Opposite, 2 pairs of opposite sides which is parallel, yes. All vertex angles are 90 degrees, yes. That angles that adds up to 360 is evident for all quadrilaterals. Okay? So you can't say it's 4 sides. Or it adds up to, say all of them adds up to 360. We're looking at special properties that is evident in this figure. Okay. Fourthly, the diagonals are equal in length. There's only 2 shapes where that is the case. What are the shapes? A square and a... How can it be a rhombus? Remember the rhombus? Looks like it. Is that diagonal the same as this diagonal? No, this one is longer. It's only 2 shapes where the diagonals are equal. The one is a square and the other one is a rectangle. Okay? Then we know that diagonals bisect each other equally. So that length is equal to that as well as that length is equal to that. That's fine. Diagonals bisect each vertex angle. So all these angles here are equal. 2. If that's 90 and it cuts it in half, then everything is 45. And the last one is the diagonals are perpendicular. Okay. There's only 3 shapes where the diagonals are perpendicular. One is a square, the other one is a... We just wrote it down earlier on. The rhombus. And there's one more. That's the case. I'm not going to waste time on you guys. The other one is the cat. Okay, there are 3 shapes where the diagonals are perpendicular. Okay. Please note this for the exam. Okay. So ABCD is a square. Calculate x and y. People, I'll just put that square back there. So what do we know here, people? Is that this is going to be 90 degrees. Not so. So what do we know? We know that 3x minus 45 is equal to 90 degrees. What's the reason then? What's the reason that that's 90? Why is that 90? So all vertex angles, angles 90 degrees in square. Okay, all vertex angles are 90 degrees in the square. You take it over, gives you 3x is equal to 90 plus 45, which is 135, divided by 3, so x is 45. Okay, so this is now 45. Now I can go with the fact that your diagonal bisect these vertex angles, which makes y also 45 straight away. But let's say we didn't know that. When we forgot about it, then we can say that angle D is 90 degrees. Why? Because the vertex angle equals 90 degrees in square. Okay. And now I can go with sum in triangles. So y plus 45 is equal to, plus 90 equals 180. Why? Sum in triangles. And this triangle ADC. So y is equal to 180 minus 90, which is 90, minus 45 is 45 degrees. Now you see all this calculation I did here? I could have just said y is 45 degrees. Why? Because why? The diagonals bisect the vertex angle. That would have gotten me all the marks. Either way. Okay? Let's go to the next shape. Still on the same page? This is the last one on this page. Okay. So here we are told that PQRS is a rectangle. So PQRS is a rectangle. If it's a rectangle, 6 properties come to mind. Opposite sides are parallel. Opposite sides are equal. Vertex angles are 90 degrees. And everything else deals with the diagonals. There's no diagonals there. You're not going to worry about doing that now. Okay? Then we told that TQWR is a kite. There are 5 properties of a kite. Okay? What are the 5 properties? 2 pairs of adjacent sides are equal. Another one. Sorry? 1 pair of opposite angles are equal. That's 2. Another one? Sorry? Diagonals, yes? Diagonals are perpendicular. That's 3. One diagonal bisects its vertex angles. That's number 4. One more. One diagonal bisect the other. Those are the 5 properties of a kite. If they tell you something is a kite, all of those things should come automatically to mind. Okay? Okay. So the question says, calculate x and y. Let's see which your x. Okay, x is here. Okay, so we know that these 2 lengths are equal, not so. So if I got Q2, I've done the job. Why? Because then I can go with sum of triangles when those 2 angles be equal. Okay. But we know we can calculate Q2. How can you calculate Q2? We know that Q1 and 2 adds up to 90 degrees. So we know that Q1 or Q2 plus 50 degrees equals 90. And why is that the case? Because the vertex angle equals 90 degrees in rectangle. Okay. Which makes Q2 40 degrees. Okay. Then we see that TQ is equal to TR. TQ is equal to TR. Why? Because two pairs of adjacent sides equal in cut. Two pairs of adjacent sides are equal in the cut. Therefore, R2 has to be equal to 40 degrees. Can you see that? Why is R2 40 degrees? Angles opposite, equal sides. Now I can go with summing triangles. So I say 40 degrees plus 40 degrees plus x is equal to 180. Sum of triangles, and it's triangle TQR. So x equal to 180 minus 80, which is 100 degrees. Now let's calculate y now. Okay. So now you see for y. Y is 9 here. Okay. So if I know Q3's value, then it's the same as y. The reason for that is because QW is also equal to W. Why? Because at least two lengths are also must equal in a kind. Okay? But we know that if we can get Q3, we've done the job. But say, hang on, this is 90 and this angle is 90. So what does that mean? That QR has to be parallel. QR has to be parallel. Why? Because the corresponding angles are equal. Can you see I'm using the converse of the theorem? Okay? I think it's the first time you're using the converse, no? Okay. So let's go with that quickly. So where do we start? We say, okay, we know that since stating the obvious, that PQR, which is this angle here, is equal to angle B, which is equal to 90. Since that is the case, we can conclude, therefore, that QR is parallel to VW. Okay, and why is that the case? Because corresponding angles are equal. Now, I can say that is now parallel. So with that being parallel, I can now say that Q3 is equal to 30 degrees. Why? Alternate angles. Q3 is equal to 30 degrees. So alternate angles with QR being parallel to VW. Okay. Now we know that QW is equal to WR. QW is equal to WR. Why? Because two pairs of adjacent sides are equal in cut. Okay. So with that being equal, therefore y is equal to 30 degrees. And why is that the case? Angles opposite equal sides. Okay. Angles opposite equal sides. Any confusion there? No? This is on the next page, no?
Yes.
Okay. So in tomorrow's lesson we're going to look at page 12 and 13. Okay. The full lesson can be found in the description box below.